Hello, everybody, and welcome back to another edition of Scaleway Sessions. I am your sometimes and forever host. My name is Dan. I am the head of developer relations here at Scaleway, and I am joined, I say, today by two of my favorite people, Eli and Diego, also on the DevRel team here at Scaleway. And we have some fun stuff lined up for you today, which I literally just found out about 5 minutes ago. I am going to be coding using a mystery language on stream today, and apparently it's going to have something to do with AI. So, Diego, what fresh hell awaits me?
So yeah, we're going to be mixing a couple of the topics that we have had in the past. The last hacking session was about AI, and we actually did make work a stable diffusion instance after 2.5 hours. We did that.
Yeah.
It was fun. It
When
was
you and
fun.
I are doing live coding together, we just don't stop. It's just like, oh, okay, I should probably eat some
Yeah.
food at some point. But yeah,
This time
Dan's
I
been on
have some nuts by my side because I'm prepared.
Nice,
Dan's been on
nice.
PTO until today this week, and left the planning of today's stream to Diego and I, and we were just like,
It's, I'm
It's
learning
his
important
turn.
lessons here today. Very good. All right. Well, look. I mean, I am in your capable hands. Just tell me what I got to do. What is the plan for today? What are we going to try to accomplish today? What do I need in order to get to a point where I can hopefully do the thing?
So first of all, we'll need to pick a mystery language for you
Mystery
today.
language. All right.
So let's go to the roulette, which has also been used in the past. Over here, we have a list of languages that we haven't used and that you don't know or you haven't used in a long time.
Right. I can only see
Right?
the little live preview thing. I can't actually see what the languages are. So
So we have Perl, Dart, Elixir, Zik, F Sharp, Julia, Rust, and Haskell.
Dan, I can see, is hoping for it to be Pearl because he does actually know Pearl.
yeah, it's the one. That's the one on the list.
If that's the case, then we will respin
Spin
because
again.
the
Oh
idea is
I shouldn't have said
for us
anything.
to do something, code with something that we haven't used
yeah.
in the past
Okay.
or in a long time.
Yeah, it
All
turns out
right.
it's really hard to make an HTTP request with JSON attached in R, or at least I couldn't make it work. Yeah,
All right.
That was a fun stream as well.
it was, even though we didn't, we failed.
All right.
Okay. Well, let's do it. Let's do it. I'm ready to go.
So let's spin it.
Yep. What is it gonna be?
Julia, it is.
Julia. Okay.
We're going through all the like data science languages.
Yeah, indeed.
I guess Lua is not necessarily that, but
Well,
we
these
had
are the
last
last
time.
two. So
All right.
Julia will be your selected language for this session. I guess we'll learn the basics of Julia today.
Well, we'll something.
I wonder if there's public like you can just open up a Jupyter notebook and then have a Julia environment and have that somewhere in the cloud that you don't have to do all the local setup. That might be a nice way for us to fast forward some of the environment stuff.
That would be cool.
I don't know if such a thing exists. It's been ages since I touched a Jupyter notebook, so
All right.
Or
I'm
a
just tweeting
dev pod environment.
or Xing or whatever it's called now, and I'm just letting people know.
gazetting.
Zing zing.
Whatever it's called. I
Yeah.
have no idea what it's supposed to be called now. There we go. Great. Well, okay. Let's try it out.
Let's
All
do
right.
it.
Let's do
Whenever
it.
you're ready, you
Okay,
can share your screen.
I am good. Well, I mean, share my screen. I mean, I'm going to open up a Firefox and type Julia programming language into
Exactly.
Yep.
That will be the first learning for us all.
it for us
What's
all.
the
Okay.
website?
So let's. I'll share my screen. How was that? Window. Here we go. Actually, you know what I will do is I won't be a complete moron, and I'm going to open it in its own session.
Smart.
Actually, why doesn't someone else do that while I take this extremely important phone call? Because stuff that happens live sometimes gets interrupted. I'll be right back.
Yeah.
All right, I will open up a new tab. Let me see of this Chrome. Let me share my screen.
And Google
And
Julia, but
yes.
programming language.
Yeah, so I'm just going to Google that so I have the tab open and then I can share it.
I was thinking, should be difficult being a Julia developer and Googling stuff? Like,
I mean, you just put programming language. This is the thing about like naming programming languages is
so you
that you
need
can't
to,
just like Go is awful to Google for. Like that's why people call it Golang, right? Because you can't
yeah,
just Google like Go help. That's an English, it's
exactly.
one of the most common English words. So, have you got you? Yeah, we can. I've got my screen
We
shared.
have your screen. Yeah.
Fabulous, cool. So we have julialang.org. Download. Julia is dynamically typed. I like that. Has good support. Feels like a scripting language. Compiled to efficient native code for multiple platforms. General, reproducible environments. I wonder if that might be where we should start.
Reading the documentation.
Yeah. Okay, this looks like more than I want to look at for the first thing that I'm looking at.
Getting started.
Right. Let me see if I can, instead of just Googling this, write Julia online. Want to try programming in Julia? Check out this web-based interactive Julia shell. Excellent. I think this might be what we want.
Good.
And then I can just loading Nick's environment. Hello world. Right, cool. I don't know how to write a Julia at all.
You can, but you don't know how to yet.
Exactly. So this is not the. I'm looking at the documentation in a separate window. What if I do instead? I'm just going to copy that URL so I can always come back to it, and then I'm going to have Julia quick start. Getting started. Okay, so what I'm looking at here is just some basic.
Yeah, you can add numbers.
Code. Yeah, and it also seems to store the last output into this answer variable. JL files. I don't know if we're just using an interactive shell and we won't really be using files. Resources, you can use the REPL as a learning resource by switching into the help mode. Aha! Okay. Begin end denotes a block of code. Okay, so variables. We can assign variables in the way that it makes sense. Is my screen of a good size? Shall I size up? Shall I zoom in?
Maybe
zoom
a bit bigger.
Yeah. Dan, if you've returned, do you want to come back to the driving seat?
Yeah, sure.
I have found
Yes.
a very useful thing, which I will post in the chat to you. And you can do it.
Are we making the assumption that Julia is strongly typed?
It's dynamically.
Is what I meant to say. Thank you.
Yep, but you can't use as a value.
Okay.
So code. What I'd like to do is have a look at making an HTTP request.
And yes, this is not.
This looks like the thing you're going to want to do. So downloads is within the able to call that. So downloads.request. So how do you access things in the standard library? It might just be that you import them. Right. I'll stop sharing my screen so Dan can share his.
All right.
Okay. My contribution here has been to find out that you can run it in an interactive shell in the browser.
All right. I believe I am sharing a screen. Let Diego do the magic there.
There you go.
There we are. So we got the Julia programming language, and I also opened up the web-based interactive Julia shell.
Indeed.
So there we go. In fact, we can assign. We have that power.
Yes.
So good for us. What I'd be curious to know is,
can you write to files?
Could we, for example, make an HTTP request from here? Right? Like what is
Is it sandboxed?
Exactly. Like
yeah, that's a good point.
How boxy is the sandbox? Right?
Can we pop this container?
Can we? Hopefully. So there we go. Okay. Well, it says right here, we were curious if it was Julia's dynamically typed. Look at this.
Yeah. No, I started by going to the main page, if you can believe it.
Yeah, Julia is in fact dynamically typed. Feels like a scripting language. Has good support for interactive use.
If you look directly below that, one can build entire applications and microservices in Julia. So looking good for being able to make an HTTP request. That is
It's-
kind of
yeah,
load bearing in those scenarios.
Asynchronous I/O, microservices. These are the good. These are the right words, right? Yeah. Okay. Well, let's try to do a thing. Is there like a? Let's learn. Getting started with Julia. I hope this is better than the Lua getting started because oh my god, that was something. That was something.
Yes.
It was something.
I mean, we succeeded.
So let's check them out. Video lecture series. I don't want a video lecture
I'm a
series.
text-based guy,
Yeah.
honestly.
Then you have books.
It's
I
true.
don't want the YouTube.
There's getting started guide in the manual. Just give it a shot.
Here we are. Yeah. Nice. Okay, getting started. Julia, 1 + 2. Okay, let's try that. 1 + 2. What about if we do it like this without spaces? Well, that appears to work. What if we do strings? This plus that.
Ooh.
Okay. All right. So we can't use
Python level
math
Python overloading of the plus
of the symbols. Yeah, exactly. So the plus appears to be just for maths, I guess.
Smart.
Okay. All right. Very good.
As a
Very
mathematician, I approve this.
What about this and that? No. Okay. Well, fair. That's fine. We'll figure it out. Control D. .jl is the extension. Here we go. Curated list of learning.
And that's where you just were, I believe.
That's where we were. Begin and end notes a block of code. I get okay, kind of like in Ruby where they use words for things, right, instead of symbols. They also use symbols too. Okay, great. Well, this is the starting. Let's move on to variables, shall we?
Yes.
This is where we can assign things. We know how to do this. We can assign, it's UTF friendly. We can say that pi is equal to 3 if we felt like it.
No, you can't.
We can't?
Yeah, error. Cannot assign a value to import of a variable maths constant.pi.
Oh.
But that's not the symbol, or that's not the... Oh, hang on. Interesting. Oh, I'm looking at the second block of code there, yeah.
Right. Redefine built-in constants and functions if needed. So we did just redefine pi.
Yeah. That's strange.
Wait,
that's not what we just got. I wonder if it's because you define pi as a variable and not as maths constant.pi.
Yeah.
So we didn't get as far as learning how to import things from the standard library of Julia.
Yeah, okay. So note to whoever wrote this.
You've got contradictory
This is
code.
mildly confusing.
Yep.
But okay. Sure, let's go with that. Allowed variable names. Well, okay.
We'll just use sensible things.
Let's just use sensible things like emoji.
Yeah.
And the Greek interpunct.
Absolutely.
Absolutely.
The Unicode X. Oh no, hang on. Wait, have they No, they haven't trademarked that. They can't.
Let's see. Variable equals value binds the name variable to a value computed on the right-hand side. Okay, fair enough. Means that assignments can be chained. Variable 1 equals variable 2 equals value. Sure, let's try that. So A equals B equals 3. B, A. Yeah, okay, that makes sense, right? Common confusion, distinction between assignment, giving a new name to a value, and a mutation, which is changing value. If you run A equals 2, followed by A equals 3, you have changed the name A to refer to a new value 3, but you haven't changed the number 2, so 2 plus 2 will give 4 and not 6. That's a common confusion?
I don't know. I mean, the next section where it talks about essentially you're doing pointer assignment.
Okay, yeah.
That makes sense to me as a Python person.
Right, okay.
B equals A does not make a copy of the array. It simply binds the name B to the same array.
Oh, well, that's good to know.
Yes.
Right, that we're not actually creating a new pointer. We're saying,
yep.
Boop.
If you want to know more about this behavior in Python, you can check out my talk, Pointers in My Python. It's more likely than you think.
There you go.
Hey, self-promo.
All right, so it just rebinds the name B to the same array.
Mm-hmm.
So So if you were to modify B, I guess it would also modify A because we're basically just creating a label, right? That's what I'm
Yes.
getting from that? Okay, yeah, that's fair. Let's make pi something more sensible. Pi is equal to 3.2. Done. Close enough, everyone.
It's not even the close. It's not even this.
Close
No,
enough.
it's fine. It's fine.
Not the
How to
closest.
troll Eli.
Yeah.
Okay, very good. Set index. Ooh, exclamation points. Exclamation points.
Now I want to
These
know how
often
to.
mean something.
Yeah, I want to know how you would use that instead of the alias of it.
Yeah, so if an alias for set index mutates an existing object in memory, accessible via either A or B.
That looks like it links to somewhere. Where does it link to?
I
could look at that in my very
alias
own.
For set property bang. Can be used to change a mutable struct. When you call a function in Julia, it behaves as if you assigned the argument values to a new variable corresponding to the function arguments as discussed in argument passing behavior. Functions that mutate one or more arguments have names ending in bang. Okay, that's what that's about. Okay, sure. Well, there's nothing shocking here so far. No.
Nothing scandalous.
Yeah, it's nothing scandalous. Exactly, right?
We didn't put Malboge on the spinner for a reason.
Okay, so fine. Don't be a dick, I guess is basically what we're saying here. Fine. Integers
Write
and
your
floating
code
point
so that
numbers.
other people can understand it.
Yeah, exactly. Literals, floating points, provides software support for arbitrary precision arithmetic. Huh. In case you don't have hardware support for it, I guess. Depending on your wherever it is you're running Julia.
Yeah.
Right? So that's interesting. I don't know how much we're going to dive into that.
Further towards the bare mental scale of things than the bare metal scale of things.
No? Yes, there you are. There you are. So we've got a bunch of different types. Signed, unsigned. They take up varying amounts of nibbles.
When you're doing Julia on your memory constrained system, obviously.
On your memory constrained reduced instruction
when you're doing
set.
embedded Julia, yeah.
Yeah, exactly.
I don't know, maybe that's a thing. If you're watching this or if you're watching this after the fact and embedded Julia is a thing, please let us know.
Let us know.
Yeah.
Yeah, let us know. Are you working on an embedded Julia or some sort of industrial project right now? Let us know. That would be really cool. We'd love to hear about that. All right, so we've got type of. Okay, well, that's good. Let's try that out. Type of 1 should give us int64, and it did.
If you do type of 1.0,
this
should give you a float.
Yes. Gives us a float. Can we do type of and then a variable? Yep,
yeah. Can you do type of type of?
I like it.
I once asked a Python instructor fairly early on into my learning Python what happens if you try and del none, and he didn't know. It turns out you can't do that to keywords. But
data type.
That's interesting.
What if you do type of data type?
Oh, it's a data type.
Okay, yeah, okay. It did say you have metaprogramming, so.
So.
Yeah.
Turns out the type of data type is data type. I'm not sure what I was expecting.
Yeah.
But okay.
Yeah, it's like type of type is type in Python, or there is a level where it's the same.
Oh, I wonder. So that's fun. Sys word size. Oh, we're on 64-bit. Okay, good to know. We can use hexadecimals. Hexadecimals to the rescue. These things, obviously. Making things signed. Yes, yes, yes. This is all very good. Very computer sciencey. Overflow behavior. Exceeding the maximum representable value for a given type results in wraparound behavior. Well, you know what? I appreciate that they tell you that up front.
Yeah, you implement your Pokemon game in Julia, and it means you can get into the champions room immediately, basically, by futzing
it's nice
the
that they're
menus.
just like, here's the deal.
Yeah.
This is what's going to happen when you buffer overflow. We're just telling
explicit
you right
is
now.
better than implicit. Yep.
Yeah, like, good. Well, thanks for letting me know. I appreciate that. Division errors. Divisions will have errors. Wait, what? There's two exceptional cases: dividing by 0 and dividing the lowest negative number
by minus
by
1.
-1. Both of those
That's got to
cases
be an
throw a divide
implementation. That's got
error.
to be a, because what if you do it because you're just setting it to negative?
The reminder
You're setting it to
modulus
the
functions
positive.
throw a divide error.
That's so strange. I want to know why that is now.
Well, I get dividing by 0 because you don't want to cause a singularity that destroys the space-time continuum.
Of course not.
But what about the second case?
Yeah, right?
Dividing the lowest negative number. Okay, what's type min?
It's like -2 gazillions.
It depends, is the answer.
Oh, minus infinity. Minus infinity in 32 bits.
In 32 bits. Fantastic. Okay, sure. Why not?
Oh, I wonder if it's because, so dividing -128 by -1 mathematically gives you 128, but that's higher than the highest in 8 because that's 127. So that's why it gives you, because 0 doesn't count for division. It's because division and addition have different identity. It's group theory. Anyway, it now makes sense to my mathematician brain.
Good. I'm happy that it makes sense to your mathematician brain. Appreciating it. All right. So numbers can float. Float. Size of float. Oh, this is interesting. Look at this right here. 4 dot and nothing after it.
It's the same as 4.0, right?
Well, yeah. I mean, yes.
Or you're saying 4 very decisively.
4. And no more. The number of the counting.
Like my old maths teacher who used to say that you could say 5 factorial by shouting 5. It's got an exclamation point after
Exclamation point. Yeah.
120 or 5.
Haha, math jokes.
Yep. It's stuck with me.
Floating, there it is. Floating point 0. You know, I had that just. I remember we were taking. I was in history class, and I when I was in doing lycée, so high school, I was living in Canada at the time, and we had a history teacher, and he said that we have to learn all this stuff because it's part of the curriculum and it's Canadian history. And if you don't know much about Canadian history, it's because there's not much history to tell. It's very boring. It's very short. And he said, "You're only everybody in this room. You're only to remember one thing. You're with me for an entire semester. You're going to remember one thing." And everybody's like, "What's the one thing we're going to remember?" He goes, "There was a fort in Western Canada, in Rupert's Land, it was called at the time, and the fort was called Fort Whoop Up. And that's the only thing you're going to remember, that there was a fort called Fort Whoop Up." Fast forward decades later.
That's the only thing you remember.
Fort Whoop Up, everyone.
I've been culturally enriched today, thank you.
I couldn't tell you anything more about it, but he was right. Oh my God.
We're serious technologists doing a serious stream.
Very serious computer people. Doing serious computer work right now. Special floating point values, everyone. What do we got? We have negative infinity and positive infinity.
And not
okay, not a number. We're all familiar with not a number. Everybody had to use cacti back in the day. It's fine. But let's talk about negative and positive infinity here for a moment.
I mean, they're on the real number line if you include infinity.
Right.
They're two different. Yeah, okay.
Yes.
They're on the real number line that doesn't include infinity. Well, now it's a tautology. What they're really telling you is that what Julia considers to be the real number line doesn't include infinity.
There you go. Fair enough.
If you're an analysis person, if you're into analysis as the mathematical discipline,
yes.
you can't. Julia doesn't like you. You're not allowed to.
Not allowed to. Not allowed to play in this particular sandbox.
Can't take limits. Can't do anything.
Nope. Yeah, no limits. Screw your limits.
You can take the limit up to max int or type max. But
yeah, you have
infinity.
bounding boxes, not limits. Is what you've got.
Yeah.
Yeah, precisely.
Speaking of boxes and boxes of sand, you can escape it.
You can escape it?
Yep.
Nice. How do you do that? Control D?
I mean, through HTTP requests.
Really?
Yep.
Well, that's fun.
So this will work.
We'll find out. So my process died unexpectedly. Am I still here? X equals 3, 2, X. Yeah, I'm still here. Cool.
Try A and see, because that's a variable you had in the previous session. Yeah.
Oh
Okay.
yeah, look at that. So
All your
I could
state,
just do that to like reset it.
all your state
basically.
has died. Cool.
Well, that's, I mean, good. That's what I would expect it to do, frankly. So, all right. So here we can add infinity to infinity, and we can do all sorts of like fun stuff. Dividing infinity by infinity is not a number.
Yeah. Sure.
I mean,
Well, to be fair, it depends how many infinities. If you divide 2 times incredibly increasing numbers by one of the increasing number, it tends to it's 2 always, and that's infinity over infinity, but it's actually 2. So yes, this is
yeah,
Eli
this
says
is-
incomprehensible maths things for an hour stream.
I'm okay with that. I got to be
Yeah.
honest with you. Yeah, no, I mean,
I'm learning.
I did get a physics degree, so I should, know 1 or 2 things about mathematics. It's been a while. So we got floats, rounding modes. Sure. I mean, okay. Look.
This
okay,
is
so
very
here's the
interesting,
thing.
but it's not going to help you talk to our AI overlords.
This is what I'm saying. Like, there's different approaches when it comes to documentation, especially in the world of programming languages, right? And what we're seeing here is like the very, sort of academic approach to this sort of a thing, right?
Which
Where
is what I
it's
expect from Julia.
it's fine. I'm not saying this is incorrect,
Mm.
right? But it's not, it's not a quick getting started. It's like, hi, welcome to Julia. Let's parse some JSON.
Yeah.
Right. That you would get maybe in some other programming languages,
Mhm.
right? That are meant to be more hit the ground running. This is very obviously aimed at, people who are coming at it from the perspective of I'm literally a mathematician, or
Yeah.
I'm doing research, or et cetera, right? Which is
Yeah.
fine. That's
Or
totally great.
statistics. Yeah.
Yeah. But okay, so look, math and the math. That's great. I'm
Yeah.
happy that we can do math in Julia. Super
Mhm.
duper. Right?
If you scroll down to standard library, you
Yeah.
can go and learn how to make an HTTP request.
So let us.
Somewhere it has the standard library, something.
So hold on. I do, however, want to spend just a little bit of time. I just want to make sure here. All right. So I just wanted to see do they prefer the single quotes to the double quotes, for example?
Uh-huh.
Right? Because it's good to know what.
No.
Yeah, it looks to be single quotey. Oh, wait,
Oh,
here,
but here,
but here. Okay.
string literals.
You can do comparisons and a limited amount of arithmetic. String literals are delimited by double quotes or triple double quote. Okay. Sure. Yep.
Mhm.
Yep.
How
Long lines can
about
be broken up with a slash. Sure. If you want to extract a character from a string, you can index into it. Yeah, fine. Looks like you use str and then the index. That's not weird. You can perform arithmetic with end, just like a normal value. Well, that's probably documentation we skipped over. That's fine. Substring
probably
extraction.
the end of the string?
Good. Substring
I think it's just
extraction.
like a bit of syntactic sugar for being able to get at the last character or something.
So if we're like x
Without
equals,
having to calculate the length of the string first.
We go x1, and it's a d. So it starts at 1. We've learned that.
One
Starts at
index.
1. Yeah. So that's good to know.
Yeah.
Okay. And then we can type of substring. It's the substring of string. Oh, good. Long string is long. And we've got Unicode.
How about lists? Because we will need that to
We will need
parse
some lists.
a
Sure.
response, right?
Where do you think we'll find that?
I would think it would be under variable types, which you're currently in right now. So if you scroll back up.
No, I wasn't in types. Now I'm in
Oh,
types.
you're not? Oh, now you're in types.
I was in strings.
Oh.
Yeah, now I'm in types. But these are...
This is how to do types.
This is types. Yes,
Yeah.
exactly. Yeah.
We could always just
So
Google
we can do
lists and
type
Julia.
unions. There, set theory. There it is, Eli.
Yeah.
Yeah.
Well, that's more like the Python typing
Okay.
module. It's
So
not
type,
really.
types. Scope of variables. Sure. How about...
Oh, arrays, single and multi-dimensional arrays.
Oh, there it is.
That's what lists are.
Yeah. That's the good stuff. Provides first-class array implementation, like most technical computing languages, even Bash. Most technical computing languages pay a lot of attention to their implementation at the expense of other containers. Julia does not treat arrays in any special way.
This is not NumPy. It will not be very fast at this, is what that's saying.
Is what it's saying. All right. Construction initialization. Right. Zeros, ones, trues. Oh, wild. Okay, this is interesting. And
they got copy and deep copy.
Oh, nice. Nice. So deep copy is a lot of fun, and I'm happy to see that it's treated as a first-class citizen within the context of Julia, because if you've ever had to do this in JavaScript, good times.
I mean, even in Python, you have to import it specially.
You can now.
You can now?
Yes.
Oh, right on. It's been a while. I haven't done anything serious in JavaScript for a couple of years. So.
No, but it was this year.
Oh, was this year?
Yeah.
Awesome. Well, good
Next
for the
time I
JavaScript
go on,
community.
Next time I have a chance to go on Who Wants to Be a JavaScripter, which is a sort of game show thing type run by one of my friends at various conferences, I'll know that for next time.
Yeah.
Like all JavaScript gotchas.
So, so deep copy, that's nice. Similar, an initialized array of the same type as A, but with the specified element type. Well, that is also interesting.
Yeah. Hey, give me the version of this that's just all trues or something.
Right? Yeah. Like I want a sparse tree, but I want it to be filled with fault. Oh, wow. Okay. Well, you know, it said it doesn't treat arrays as being special, but here we are.
Well, in terms of the in terms of like the low-level manipulation of them, it's just got a lot of syntactic sugar about
an array of the same binary
stuff.
data as A, but with element type T. Reinterpret TA.
Interesting.
So
what is Julia implemented in? Is it on top of C? Like, can I go and look at the implementation of this in a language that I can comprehend, or is it? It's LLVM. So.
Support Julia version. Well, there's a Julia version manager. It's Rust-based. The manager is Rust-based.
Yes.
Why is it not Julia-based, I wonder?
The person who took on the project of writing it was a Rust person.
There you go.
Open source.
Okay, well, whatever. We can find that out. So here we are. Zeros.
Oh, array literals. Yeah, is how to do like a list of actual stuff.
There we go. Okay. Here, 2, 3 is a tuple. Sure. Array literals. So here we go.
Yeah.
An array of ints. Well, sure. Now, what is this?
That is how you do fractions, apparently.
Fractions. Huh. Okay.
I wonder what happens if you put a non-rational something that can't be represented finitely in base 10. If you put 2/3 in there, would it give you a rounding?
Let's find out.
Yeah. Yeah, if you just type in
2, 2/3.
Yeah.
3 element.
Oh, it gives you all of them as fractions.
Wild. Okay. Really?
That's cool. That's weird.
But that's not what I expected.
Yeah. What if you do 1, 2.3?
Yes. 1, 2.1,
2/3.
2/3.
Okay, it gives you an approximation. It takes the first thing that it has to do. Because all of those can be parsed as fractions. In the first example, it does fractions.
What if we
and then in the second one,
terrible like this?
Yeah.
Yeah. Okay.
Okay. You can't
okay.
do. Anyway, that's just 0.7 anyway, so you wouldn't write it like that.
But like I said, we just do something terrible, right?
Yeah.
Yeah. So I was not expecting that.
Yeah.
That is.
It makes sense now that I've thought about it, but it's also why. Yeah.
Yeah.
It's giving them all the same representation. It's just that 2 of them happen to have 1 as the denominator.
Yeah. Yeah. Of course. Whoops. Is that me typoing? There we go. There we are.
Oh.
It's okay with that.
Yeah.
Yeah. Interesting.
I guess you've told it you want to know what things are in thirds.
Yeah.
But then with the other one, first you typed a decimal, and that meant you told it what you wanted in floats. You're telling it implicitly, I guess.
Wild.
display these as floats.
So we can stay here.
Okay, no, this is great. Diego's like, I want to make an HTTP call, and I'm like, no, let's play with friggin' arrays.
We can after we get.
Oh, here's the concatenation. Look, we can concatenate. There we go. We're curious about this earlier. If we could use pluses or ands. Look at this. Comma, no concatenation. Semicolon, concatenation. Interesting. But only for arrays? Sure. Okay, you know what? I think we've learned enough.
We'll come back to it if we need it.
Why don't we networking and streams? That sounds like a thing, right? So write standard out hello world. Sure, let's do that. Look, there's a semicolon at the end of it. Express return value 11 with semicolon. I wonder why. Well, let's do it without and see what happens. Hello world 11. I guess 11 is success.
So what if you type something that you've been getting output from before and give it a semicolon? So like x equals 2, and it would normally print you.
Oh no, it's the number of characters. Look.
Oh.
Ah.
That makes sense.
That makes sense. X equals 3. And we'll just X. Huh.
What? Is that it? Is it because it's a byte? It has length 8?
Maybe. That was unexpected.
So we can't do that.
We can't do that.
Catch me doing a new lightning talk that's like Julia Watt. I probably already exists.
Okay, so that makes sense, right? It's a string.
Yeah. I wonder if you can cast things to string. You have to cast them there. I love that.
Sure.
Yeah. Maybe we can just use the library, the HTTP library.
I don't want. I've had enough of your sensible attempts to put this stream back on its rails, Diego.
Well, when we start getting that symbol with a little question mark in it back, or when we start getting that as like the return value from things that we try to do,
exactly. Yeah.
We'll know. We'll at least have seen it before.
Yeah. So, okay, well, we can write. We can work with files.
Resolving IP addresses might be interesting.
Sure. Let's resolve an IP address. Connect methods. It does not follow the listen methods. Well, we didn't learn about the listen methods either. So what's up now? Which will attempt to connect to the host given by the host parameter as a port given by the port parameter. Let's do things like this. Connect to Google Com on port 80. Sure. Why don't we try to connect to Google Com on port 80?
Connect. I wonder if you have to
Oh, yeah, I gotta have some sort of a something first, don't I?
Yeah.
Yeah. Okay. Fine. Simple TCP example. Using sockets.
Yes.
Right, let's do it. Using sockets.
Okay, the hard way. Good.
Yeah. Well, yes, the hard way.
Good. I like it.
So listens. Oh, we can set up our own socket to listen. So this is it's the equivalent. That makes sense. Listen on all IPv4. So we're not binding. We're saying no, like all the interfaces. We have also domain sockets and a Windows name pipe. Wow, look at that.
Wow.
Sure.
That's
why
computing.
Not? Yeah. So connect. Sure. All right, because we didn't actually set up a thing. We'd do this one first, right? We'd do listen 2000. Yeah? All right. Listen 2000.
Cool.
Connect 2000. And we suspected we saw hello world printed. Really? Oh, right, because we didn't actually write any code. Okay. Yeah. I assure you, I am a professional computer person. Do not try this at home.
Learning in public.
Yeah. Oh god, this is the best. See, this is the thing, right? When you do a live stream, you actually start to see like how people. This is how my brain works, right? I'm just like do do do. You can't quite see the monkeys with the symbols getting smashed together in my head, but they're there, right? All right, fine. So, resolving IP addresses. Well, let's try to do this now because we have sockets now, right?
Yes.
Ooh, look at that. We connected. And we can get adder info, which that seems pretty normal as well.
Yep.
Awesome. So sockets. So in my mind, I got to be honest with you. If there's something in standard lib called sockets, I don't expect it to do DNS resolution.
That's a good point.
Right? It does in this case, and that's fine. Whatever you do, you Julia. Right? But that feels kind of odd to me.
It feels like it's a mix of high and low level stuff.
Right?
Yep.
Like I feel like I would need something else to make that happen. And now they're just like, no, sockets. Yeah, but like DNS is not a socket.
There is a separate, it's called downloads, standard library thing that we saw briefly. And that has a request function to make HTTP requests.
Okay.
In a very, the same as this, essentially. So using downloads, you can do request and then pass in the URL and have
Where's
payloads.
downloads?
And I saw it in, yes, go to standard library.
Standard library.
Downloads.
This
is what came up when I searched HTTP, essentially.
Download a file from a given URL.
Excuse me. And then the request function within this library. There we go.
Saving it. The output can also be an IO handle. Okay, sure, why not? Unixy, very good. Downloader keyword arguments provided. It must be a downloader. Okay, fine.
If the output is a command, the command is run.
Nice.
Handle with caution.
Oh, the potential for foot gun here. My goodness. Delicious. Progress keyword arguments provided must be a callback function, which will be called whenever there are updates about the size and status of the ongoing download. That's kind of neat.
Yeah.
Right?
You're downloading like a massive data set from somewhere and you want to know how long it's going to take so you know how long you've got to make your coffee.
That is interesting. Huh. Okay, sure. Verbose option set to true. Libcurl. Oh, it's libcurl under the hood. Okay.
In that case.
So here we can use downloads. So it's interesting. It's called downloads.
I know.
Yeah.
Right? Why downloads?
Yeah. I would have expected this library to be called HTTP.
HTTP, maybe? Yeah. So sockets can do DNS resolution, and downloads is your HTTP library.
I guess. Naming things is hard.
I'm not... Yes, you're correct, Eli.
Although it does say for HTTP requests if an input stream is given, which implies that it does other kinds of requests. Like the fact that right below your cursor and a little to the left.
Yeah, okay.
Yeah, it says the fact that it's specifying for HTTP or HTTPS requests.
Yeah.
Something. Not just something.
I am not following your logic there, but that's okay.
It says make a request. For these kinds of requests, if this is given, blah 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 blah.
Yeah.
Why is it specifying for these kinds of requests unless there is other kinds?
Yeah, but also why is it called downloads?
Well, yeah.
Yeah. All right, fair. We got our struct here for the response. It has the following field. Yeah. Message headers. This is all just taken from...
Oh, it's like SIP and stuff. That's not HTTP. So maybe you can make SIP requests with this.
FTP.
There we go.
Yeah, okay. That was what to say. This is weird if it's HTTP.
Yeah.
That's because it's not.
There we go. Okay.
There we go. Okay. Fair. You know what? I want to issue a public apology to the core development team of Julia for besmirching your good name on stream.
Retract your snark. Yeah.
Downloads remains a silly thing to call this, nonetheless. So
It could just be requests. I mean,
could be requests. Yeah. Is there something else already called that? Maybe. No.
Nope.
Okay.
Oh well.
Sure.
Cool.
Okay. Great.
We've got to fork Julia, patch it to call this requests, and then we can start using it.
And then re-release it. A Scaleway flavored Julia. What a great
And then
idea.
3 weeks later, we might get to Diego's challenge.
Yeah, we're already 48 minutes in. Diego, what's my challenge?
Your challenge is to query an API.
I don't want to do that.
Sometimes in life you have to do things you don't want to. That's called work mainly.
It's called exactly. You mean I don't get paid to poop on random programming languages documentation on stream? That's not actually my job.
That's part of it.
Okay,
now let's use that language to perform a task and demonstrate its usefulness.
I did not mean to click on that, but I did. That simple Julia wrapper on libcurl. Please see libcurl API documentation. Well, okay, great. I'm just going to go back one. Okay. I guess we could try to do that. Do we have an endpoint in mind, Diego?
He has put it in the chat.
The endpoint is in our internal chat.
Oh, okay.
I'd recommend just saving that as a string.
It's okay to share that.
Yeah, it's fine.
It's not scary.
Yeah, I know.
Okay. Is its output arbitrary code that you're going to run in this Julia shell?
Right. So I just tried to connect to it super quick on localhost, and it can't connect to server. Is it up? Whatever that is.
It is up. It's going to give you probably a method not allowed or something because you need to send that.
Couldn't connect to server.
Let me triple check because that may mean our instance is doing something weird.
The DevRel account, Scaleway account, has been shut off because I used it to run too many Minecraft servers.
Yeah. Define too many, though. I mean, like 1,000?
For the purpose of our job, 1 is probably the cutoff. Although I was at PyCon US, not this year just gone, but the year before, and I saw a great demo in Minecraft for quantum computing. It was run by a guy from IBM, and he had set up essentially while we try and get the actual challenge working. I will tell you a story, and it was Portal in Minecraft, but the challenges you had to solve to unlock the next room were complete this quantum computing circuit using Minecraft blocks to represent circuit elements.
What?
And the cool thing was that the back end of it, like the actual server that was driving, taking the responses, was actually an Anvil server, which was the company that I was working at the time and whose booth I was at PyCon being on. And that was why I saw this demo, is because she was like, I used Anvil to do a cool thing. And I was like, Anvil is the least cool part of what you're doing here. And I almost did a hard pivot to go and try and learn quantum computing. So very cool demo. And it was Minecraft. I thought that was amazing.
Awesome. So how are we doing there, Diego? All right. Well, we let Diego deal. Let's find out.
Diego is in incident response mode.
HTTP, in the meantime, you can just send an HTTP request to a Echo server.
Julia. Right? There, that's better. Apparently you use this.
I guess, but then you have to learn how to do, because that's not in the standard library. You're going to have to learn how to import stuff into that shell. Or
client and server functionality.
Actually,
I don't know.
Yeah, you can actually run that command and that will import it. Yep, that works.
Using package add HTTP.
Okay, so it is giving you like a temp directory essentially for this.
That's nice.
I guess it's just running in a container somewhere.
Okay.
Very cool. This is a great little REPL. This is a great learning tool.
Yeah. Look at
Props to the Julia Julia
team. Whatever Replit is.
Oh, Replit, of course. Yeah.
There we are. So we're adding, we're using a package manager here, obviously, which was apparently written in Rust. I think it was what we.
Oh, was
what
it
we had
using Julia
determined.
up?
No, that was the version manager that was written in Rust. The package
Yes.
manager itself might be written in Julia. We actually don't know.
Yeah.
That's not
Haven't-
information we have. I'm really enjoying the text mode going on here. This is balm
really
for my
nice.
soul.
It's
This is
very
really
like
nice.
hacker
Yeah.
man, like I'm in, you know?
Yeah, yeah, I like that. Oh, I wish I had a hoodie that I could go whoop like this. Right? That would be nice. Hold on, I got my hacker glasses over here. Hold on a second. There we are. Put them on. Perfect. We're in.
Oh, I love
All
to
right.
pre-compile my dependencies.
So we have 16 dependencies successfully pre-compiled in 28 seconds. That seems reasonable. What kind of stuff do we have in here?
So I would.
Flags. We've got a zlib, HTTP, logging extras. Of course, some TLS stuff. Streams, buffers, URIs, OpenSS. Wow, there's a lot of stuff in here.
Diego,
Okay.
what's the sit rep?
The server is back up. So
Server's back up.
you're good
Okay,
to
method
go.
not allowed. Good. So we have. We're not gonna. So we're using HTTP request. Great.
Yeah, I would
That's what
advise
we're doing
against using that example because you will leak your IP address, which is
This one
I
right
don't
here.
know, something you probably
Yeah.
wouldn't like.
Yeah. Well, no, but they would leak their IP address.
That's true. This is
That's
not our
true.
computer.
Yes.
Right.
Yes.
So let's leak theirs.
We're in the
Yes.
cloud, Diego. It's
Yeah.
someone else's computer.
Let's leak their
That's
IP address.
smart. Unless they
Unless
get your IP.
Hold on, I gotta.
Something undefined.
I have to. I have to do the thing.
The using.
Oh, using.
Is it using? Oh, tab complete. Look.
Oh.
Yeah. And will it tab complete for you HTTP?
That's what I'm trying. Whoa! I hit tab a bunch of times. Look at that. Look at that.
That's very nice. Oh my gosh.
Okay, you know what? I'm digging it. This is all right.
I've got some friends who have been trying to convince me to learn Haskell. I'm like, nah, I think it might be Julia actually. I might pick up Julia as my next thing.
So we've made our request. No?
Takes some time. It's free resources.
That's true.
Need some patience.
It's free real estate.
You want that progress thing, don't you?
Yeah, I do. Why isn't that on my default?
Yet DNS resolution is too much.
Oh, hey.
Yeah. I think it might actually be an issue with HTTP bindings. I tried it on localhost and it's taking forever as well.
Oh, okay.
So that's okay. In fact, on my side, I got a gateway timeout.
Oh.
So something's going on with whatever that is. That's fine.
We don't need it.
Let's not hurt them. Yeah, that's okay. So look at this. We got our HTTP messages response. We got our header here. It's human readable, and then we got this is the body here.
Yep.
I have not used this service, but I'm assuming that's the body.
Yep.
Right.
That would make sense. Okay. It's in curly braces.
Yep. All right. That sounds good. I just tried it from localhost, and yes. Okay, good. All right, so that's good to know. We got our status. I strongly suspect we'll do exactly what we suspect. Precisely. We got our status back. That's just a property there.
Mm-hmm.
Do they call it properties in Julia? I don't know, but there we go.
No time to find out.
Yep. Super duper. And we'll print this. Now hold on. So we got this. What if we don't do that? You int 8.
Oh, it's an array of
Oh, it's an array. Yeah. Okay. That's fair. Yep.
What?
What just happened?
destructive readout? I don't know.
I'm about to say, is it? Did the message self-destruct? What? Oh my goodness.
Oh, you're printing lines, right? You're stepping through the lines of the body.
Oh.
So it's a generator thing, probably.
But
Okay, maybe not then.
Ooh, this is okay.
Spooky.
Now that's spooky. I don't know how much I like that. I'm not gonna lie.
Well, let's see if the behavior it becomes a problem for us when we're trying to actually do Diego's challenge.
Yes, which
So-
I have been stubbornly refusing to get to. All right. So we can also set up a listener, and we can also do WebSockets. Okay.
cool.
Cool.
Maybe you can do that in the future.
Maybe.
I want to come back to Julia after this stream. I think it's nice. It's cool.
Actually, it's so far kind of interesting. HTTP open sends an IO stream from which response can be read. So we could get ourselves some Bach.
To get
Hello,
Hello,
us.
sweet one. I think I've played that on the horn.
And dump that directly to VLC.
Huh.
So it's a
Does this
For example-
container that we're running in
Yeah,
have
exactly. Have
VLC?
VLC, and where will the sound output to? I'm imagining like there's somebody this is running on their computer.
There's like one sysadmin somewhere who is responsible for running these containers, and it just starts
Yep.
playing stuff in their home.
Yeah, I like that.
It comes out of
So
their
hold on.
smart fridge.
So hold on. I'm going to try it again. Right, so we've made the request,
Right?
right? We're agreed.
Yeah.
I'm
Again.
going to do it one more time.
Spooky.
Ooh, why is it doing that?
Not idempotent.
Oh, boy, I do not enjoy that.
To be fair, we should. When do you actually need to print the thing? Can we not just let it do the standard out?
Look, the body's just gone. Look. Gosh, that's weird.
I'm gonna go and look up print line and see what it actually does.
Yeah, because now I'm very curious. Like, okay, is there a reason? Yes. And once we know what the reason is, it will no longer mystify us. But for now, that feels really weird. Right? That feels weird.
It does, yeah.
Yeah. So Eli's on the case. All right, we can make a request, Diego, successfully.
Yes. So we need to send a post request to the URL that you have there.
Okay,
Yeah.
let's make a post request. So HTTP request instead we'll do a post,
Yeah.
right? So let us use the power of the up arrow because I'm very lazy. Post. And it's
I think
okay to
you
put
mean
the
you're
URL here,
efficient.
Diego? Is that okay?
Yeah,
Are we
it's
leaking
okay.
that?
Yeah.
Yeah, okay. And we'll just do like so.
You can create servers with it. That's cool. And then you need to send a JSON body.
Wow, that's really fancy. There's a lot going on there.
Fortunately, it's not our problem.
Yep.
I love it when things are not my problem.
This is a lot. I mean, thanks for the stack trace.
Oh no, wait, you did post to the thing. I thought you were
Wow.
posting to the bin. Never mind.
Wow. This is a lot.
Unprocessable entity.
Okay. Okay, fine. But like this is what I wanted. This is like this is the part I want, and then it gave me so much more. Oops. Infinite scroll. All right, here we are. Wow. Okay. There's got to be a way to make that less noisy. You think?
Yeah, there's going to be some verbosity level that you can set in your
Yeah.
like. It might not be in here. It might be in Julia itself.
Perhaps.
Like, oh, you know what? I bet it's in the logging dependency that got installed as part of this.
Yeah, perhaps. Is this all one page? Nothing about web pages. Okay, that's fine. Sure. Well, we're a client. URL headers, body. We're going to send it. Obviously, we're going to be posting something. What's the thing I'm going to be posting, Diego?
You're going to post a JSON object with the key value, the value string,
Okay.
any string, and this string will be passed to Stable Diffusion and will be interpreted, and it will make art for you. So whatever you specify in that string,
Okay.
it will create a picture, a nice picture, that will send you back in the response.
You can ask it to make you an image of the abstract concept of using Julia to query Stable Diffusion.
So first, I need a valid JSON. Let's say object, but I guess a string ultimately, right? That's just JSON formatted.
I mean, try it.
Would that? Do you think that would be fine? So it's going to be value, and then ice hockey on the moon, for example.
Yeah, do it.
Right?
Yep.
Oh, I'm typing. I'm typing in the wrong terminal. So let's go with thing equals boop, and then hold on. We will use the magic since we learned about this earlier, right? Do you think this will work?
Yes. That worked.
Nice. But it's got slashies in it.
That should be fine.
Should be okay.
I think that's how Julia is rendering it to you as a string.
You think?
In the terminal. I don't know that that's what it will be sent. I think that's a representation that you're getting in the standard out. I don't think that's what the actual string is.
Well, hold on. Let's find out. Thing equals. What if we do that instead? Nope. Okay. Didn't like that. What
Yeah,
if?
because I think there's a difference between strings and string literals.
Yeah, and then we did that. We're just playing around now at this point, of course.
Well, whether like strings and quotes and stuff, so that's the exact same.
Yeah.
Is
Okay.
where one of the things we fell down with when we were doing R. So.
All right. So we've got a variable with,
Right.
and it's a string, and the contents of that string is what we hope to be valid JSON. Right?
Yep.
All right. That sounds good.
I'd say that you should also send the content type header.
Ah.
But that one is easy.
Is it?
Apparently.
All right.
That should be something that the HTTP
You should be able to
library
just do that.
is lets you do easily.
Yeah.
So
you need to dig inside the examples folder.
Oh, there's an examples.
And then there's the client. There's no client there.
Oh wait, do you mean the examples here?
Yeah. So are we looking at the same library? We are docs. Yeah. So in the docs examples. Yeah.
Okay. Oh, this is it. This is the same thing.
It's the same thing.
It's the exact same thing. It's the same thing.
Then I was looking at something else because I'm looking at a markdown file. Docs, examples, and then SRC.
Yeah, you're looking at this.
Yeah.
Right?
Okay. Client.md. Sure. Nice.
Yeah.
No, it's not that. Oh my God.
But
What?
Well, no,
if you go back to client.
Client. It's this.
Yeah, it's that.
Right.
It's
there
this.
you go. Yeah.
Yeah. Okay.
If you scroll down, there you go. Headers. You passed it.
Passed. Oop, there it is. You're right. Oh,
So square brackets, then
yeah,
the header.
No, it really just is formatted like this. Yuck. So here's a space where we can open up a pull request. We'll format this a little better and do some positive, meaningful contributions to the Julia project a little later. But okay. Verified as a vector of pairs or a dict. Sure. Yeah,
what I would
that's relatively
start wanting
straightforward.
to do at this point is to be able to construct a request object like
Yeah,
in bits and then send that. But I don't know if
Yeah.
that's a thing you can do.
that would be okay to be able to construct an object. I would like that. So
I think that was after post. That's the parameter that should
Yeah.
put there.
this is the thing that gave us the stack trace, which was just great.
Mm-hmm.
So post. So where do we actually give it headers? Like I actually, here we are.
I think it's a certain
Method URL. Okay. Yeah, method URL. We're good so far. Method URL. Just keep going. Okay, great. So headers, which we can pass as a vector of pairs. Yep. Okay, great. So you want content type?
And I guess you want what application JSON?
Yep.
JSON.
Cool.
Okay.
Now you need to construct the body.
Yep. Then that's going to be the next one. Fair enough. That makes sense. And the body is always the body like a post story put makes sense.
Any abstract string which will be sent as is for the request body, and that's what we want. The third.
Right. So in fact, we
bullet
could
point
put
there.
thing here
Yes, we can.
in principle.
That is my understanding.
That is what it looks like to me. Yes. Okay, well, let's hit enter and find out.
And now we wait.
Well, it did not puke a stack trace back to us immediately.
Oh my gosh!
Look at
You have
that!
there.
Wow, it's beautiful.
So that's a base 64 encoded image then.
It
So
is.
Can we
It
go
is.
online and dump that into some kind of thing that will spit us back out the image?
We can. We should.
All
However, I don't think that's the full body. You probably need to.
Oh, look at this! Look at this!
Oh my gosh.
Look at
Yeah,
Okay.
you probably need to query the exact property. So R that the thing
Do
that you
print-
did before.
Do print, not print line.
Do print, but not print line.
See if that eats it from you.
Like so?
Yeah.
Yes. It's a significant image. You've created art here.
Wow. Well, I'm digging it. I really like what the AI has done with the place.
Oh yeah, and you've got all sorts of stable diffusion.
Stable diffusion stuff at
At
the
the
end of
data,
it.
yeah.
Yeah,
Info.
exactly. Exactly.
But you can just get the images array value.
Or how do we get that?
You could copy and paste it, or we can find out and see how you access a JSON object.
Yeah, it'd be so here's the thing. So what we've got is body, right?
Yep,
Which is an
as a
element
string.
in is an element in an array, apparently. And
That is a string literal, it looks like.
inside of it,
Yeah.
and what is represented is more JSON.
Yes.
So we need to pass this. I mean, we could write a JSON parser in our free time. I suspect there must be a JSON library for Julia.
It is a vector, actually.
It's a
the body.
vector. Okay. Okay. It's a vector.
Ah.
Very good.
So maybe you
Can we-
could. Can you?
Can we just like?
Vector square brackets.
Yes. Ooh, getting laggy. Uh-oh.
Try just one.
I
see
feel
what
like
it does.
I feel like
Images.
I'm on dial-up here. Let's try that. Nope.
Does it exist?
0 element at index 1. It's a 0 element vector?
So was it deleted?
Oh, maybe it was.
Oh no!
So while I was looking at whether
Oh,
or not
no.
what print does to the thing,
Yes.
like I think it expects like an IO stream,
Sure.
and so it is consuming the thing as it prints it. I think.
Oh.
Yeah.
Okay. Okay. So you know what? We said that it feels weird, but we don't know why. If that's the reason,
That's
a reason. It's a reason.
That's what I understand.
Yeah.
I could very easily be wrong though.
No, I mean
as in so many things.
but that is it's not a behavior I would have expected, but if that's the behavior,
It's consistent at least.
it's consistent. Yeah, that's not weird.
I don't know how you would print. How do you do a non-destructive readout of a thing you've
Like if
got
it's
though?
well, there's the if it's a stream, it's a stream.
Well,
right?
no, you know
It's
what you
just-
can do, Dan, is don't do print. Just call the thing, and it'll do it to stand it out. Like when you were doing x equals 3 and then doing
fair
x.
enough.
You don't need
Fair
to print.
enough.
Just do the thing and let it do its printout that it will do naturally.
So
If
okay,
you
so
make
we're still a little bit laggy here.
I think you're going to have to make that request again because you've
Oh yeah,
lost
of course I'm
your
gonna have
thing.
to make the request again. But oop, there we go. We're back. Ooh.
Actually, you can set the type of response stream.
It's pretty slow
So-
here. I think we've
Might need to start a new session and
we might
import
need
all our
to- right,
stuff
yeah.
again.
This is unhappy with us, which is fine. So here, let's.
We have been doing horrible things to it, to be fair.
Here we go. Want to try programming in Julia? Sure, I'll give it a go. Whoa, whoa, look. Interesting. Huh.
Okay,
It
cool.
kept our history.
Very nice.
Okay. Well, that's all right.
Has it kept
Has
the
it?
imports?
That's what
and the
I'm
install?
curious about. Well, we're about to find out, aren't we?
Yeah. Yeah.
Wah,
That makes
wah.
sense. So it was
Yep.
what, using package.add.
We had to do the package add thing first.
Yes.
So we'll do in the grand tradition of system administrators since time immemorial. Just hit up to
Yeah.
get what you want. Okay,
You
so this
can
will take a
start
second. We know this doesn't take that long, but
Mhm.
while this is going, thoughts on Julia so far? What do we think?
I like it. I feel like these are fairly normal amounts of teething issues
Mhm.
in terms of understanding how to do a thing. Like we've got to make an HTTP request pretty fast.
Yeah.
Yep.
This interactive shell is what's unlocking that. If we'd had to spend ages faffing around with installing and environments and stuff, that probably is a bit more painful.
The power of Nix. Yeah.
Mm-hmm.
So big +1 for like DevBox type technologies.
All right.
Nice. So well thought language. We are not using it for what it was meant for, definitely.
That's part of the fun of
but-
this, right?
Well, that's it. That's
Yeah.
exactly it, right? Yeah.
But we can make it work, right? Without you aligning with their goals. We can make it a query or API quite
Well,
easily.
I would say like, there exists an HTTP thing, and it looks like it. Do you remember when we looked at? I think it was Lua, and there were a bunch of different ways we could have done it. Or there's been a few times when we've done languages and we've gone to look for what's the way to do this, and there's like 3 different ways, and some of them don't work, and some of their documentation doesn't work. Whereas we looked at HTTP in Julia, and there was like a package that does have docs that seem pretty good.
Right.
Yep.
All right. We've got our response.
All right. So now if you just type r.body and then square brackets 1, see what it does. Huh.
Wait, so it's still there?
Yeah, it's still there. That's nice that it's still there, right? That we didn't destroy it with
Yeah.
print ln by accident, which is nice.
I feel like it's got every single character of that body as its own element in this array.
Interesting.
I think it's done like you know how like a C string is just a list of characters,
Yep.
null terminated.
Yep.
I feel like that's how it's parsing this thing that we've got. It's an array of bytes.
Yep.
So speaking of parsing, what if we imported a JSON, a
What
JSON
if-
parser?
What if?
Right.
Why not, man? We're here, right? So let's are we gonna just guess here?
Import JSON.
Let's just take a guess.
Yeah.
See what happens.
Oh,
Look at that.
very nice.
Nice.
So even if the core library, the standard library thing is called downloads, and it's a bit of a silly name,
Yes.
clearly the people writing third-party stuff know what's up when it comes to naming.
The thing is, I get it, right? So like, someone came along and went, you know what we need? We need a programming language for doing
A download.
maths and weird science stuff.
Yep.
Right? And somebody went, oh, you know what? But like, there's a CSV
That
with
I
a bunch
need.
of files in it that I need. Can we just download it? And someone went, yes. And that became standard lib.
Yes.
Right? So
and nobody hates it enough to fix it with breaking changes.
Right? So there you go. So we got JSON now. Look at that.
Right.
Should we see if there is documentation for this new thing shiny new thing we've added? Or just go. Just see what happens. Try and do JSON. Try and do parse.
That's something.
What if
JSON, that's something.
JSON. Yeah, exactly. JSON.
Oh.
I'm tab completing here. It's not. Here we go.
Yeah.
Parser.
Here we go.
Parser. Yeah.
Parser.
That something. Well.
Oh, it just takes a second. It just takes. I'm very lazy and impatient.
That parse
Parser.parse. A parse array, maybe.
Parse?
Parser.parse.
Parser.parse array.
Parse
might be the
array.
thing.
Parse object. JSON parser parse.
So, yeah, parse.
Yeah. What does it allow? String.
It wants an abstract string, but what we've got is an array. So
yeah. So can we then go string our body?
Maybe hard body.
yeah.
Without
See
the
what it
string.
does.
Let's see what it does. Look at that.
That's
Look
gorgeous.
At that.
That's the most beautiful thing I've seen all week. I'm lying. That's my cat, but
Yeah, no, that's nice.
All right.
That's very nice. Okay.
so I
There?
wonder if you can then index. I wonder if you can do that and then
Yeah.
square brackets images
Yeah.
like that. Yeah.
Like here?
No at the
No,
end
here.
because you want it. You want to
Yeah.
be no the other thing. Yeah.
Here.
Yes, because it's the return of that. I think you want that in quotes.
Strings. Yeah.
Right.
The images in quotes.
Oops. Yes. Boop.
No, you don't.
That's
Okay,
the
how do you get
dictionary.
something from a dictionary? It's not the Pythonic way.
Yeah. That's okay.
I'm going to cheat and go look at the documentation, but I won't tell you unless you want me to.
Is a dict the same as an array? In the parlance of Julia?
I don't think so.
Because if it's not, maybe we need to access it a different way. You know what? I'm going to have to call it soon. I know that we like these live hacking sessions to go super, super long, but I did not plan to stay on for hours.
This is a very good point.
Yeah, so I'm going to have to leave. Y'all can open up a session. Feel free and keep hacking. But I do personally have to run.
This is about where we got to on the R. I feel like this. Honestly, we made
I mean, we have
HTTP
the
request.
response.
Yeah.
We got the response.
Can we copy it
Yes.
right? Like we could.
If you just print that out, because remember you managed to do that before and got like a zillion characters into your terminal.
Oh
Yep.
God, it was so gross. But yes.
Yeah, but if you copy that, there's going to be somewhere online we can dump that and get the image back out.
All right. Well, we'll just make some space here.
Mm-hmm.
Okay.
In the meantime, I will find somewhere online we can just put that in. Here we go. The first result looks like it'll probably work.
What happened to?
Was deleted.
What happened to our body?
Our beautiful, beautiful body.
Our beautiful, beautiful body. What happened to it?
Maybe
gone.
make the request again.
Why does it keep disappearing? I don't like that.
I think it's because of the.
Oop. Oh gee.
uh,
Oh my. Oh, what's happening?
What was all that?
Wait, hold on. Things. No.
Yeah.
Okay, whatever. I gotta go. So, debugging the Julia REPL is left as an exercise to the reader.
Very apt for a mathematically, a mathematical language.
Precisely,
Oh,
but here's the thing. I think
it's obvious that
it's obvious that
anyone
it
can
follows
see
that.
Yeah,
exactly.
It's trivially true.
It's trivially true.
You completed the challenge. That's
we completed
what
the challenge. We
yes.
took a programming language I'd never seen before. We looked at the documentation. We were lucky. We lucked out that there's an online REPL that we could just play in, so that was nice, right? Instead of having to install it on localhost and blah blah blah. But then I didn't get to show off my cool font that I like to use in my terminal, so that's for another day.
Yeah.
And then we were able to successfully make it have behavior we didn't expect, which is always nice because it gives us something to go read more about and learn more about. That's always fun, right? We were able to figure out package management within the REPL, so not having to use an external package manager as part of your operating system's interface, like a terminal, for example, but actually inside the REPL itself, you can do package management, install packages, learn how to load those libraries into our scope so they can actually be used. And then we are actually able to use one of those libraries to make a HTTP requests. We made a GET request. We made a POST request where we actually sent information. We sent a JSON body, a payload, right? We were able to receive the response, get more weird behavior that we didn't expect, which is always fun, and got really, 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 really close to actually extracting the image. What we actually ended up getting was a nicely formatted JSON object. And we could have, if we wanted to go a little further from that, have extracted the base 64 string and put that into a base 64 decoder, right? And gotten a picture out of it, which we did not do, but that's fine.
That's fine.
That's fine. But we did the thing, everyone.
Woohoo!
So congratulations. Success, Julia, everyone. Julia.
Right. Before we wrap up, do we have things we want to plug?
Do we have things we want to plug?
I do. The reason I say this is because I'm speaking in Copenhagen at the end of this month. Well, I'm not actually sure which day I am. It's the end of the month, beginning of September, at Copenhagen Developers Festival, and I'm going to be talking about web authentication, which is always fun. That's a fun talk to do.
Excellent.
Lots of new and juicy stuff on passkeys in there this time as well. So that'll be good.
Fantastic. Glad to hear it. I do not have anything to plug. I've come back from vacation for 1 day.
I've been subjected to this.
It's been subjected to this, and then I'm leaving again. So if you are, for some reason, going to be in the Chicagoland area, Chicago, in the American state of Illinois, in the United States of America, I've never been there before. I'm going there for the first time on Monday for DevOps Days Organizers Summit, and then DevOps Days Chicago is next week. I will be there. I am blissfully not speaking at that conference. Really, really looking forward to just attending a conference and learning. And if you're going to be in Chicago and you're going to be at DevOps Days, let me know. Would love to hang out. Is that
Diego.
the image, Diego?
That is your image.
That's the image? That's ice hockey on the moon?
Yeah, your prompt engineering skills may need some polishing, but yeah, At
Sure.
least the AI did its job.
Yeah, definitely. AI did a great job there, Diego. Really
Yeah.
solid work. Solid work.
Amazing.
Excellent. All right. Well, on that note, thank you so much, everybody, for hanging out with us. This is a lot of fun as always, and feel free to send us your language suggestions.
Yeah.
Feel free to send us your challenges. Please don't make them too hard. And
As we just told them, there's a limited amount we can get through in
it's
an
limited
hour
amount we get through an hour and a half.
with the number of
We're doing
detours
it.
we like to take.
Exactly. And as always, thanks for coming along. We really appreciate it. It is the summertime for us where we live physically, and so as we roll into summer, if you like the sun, enjoy the sun. If you don't like the sun, hide from it. But do whatever makes you feel good. And as always, everybody, stay safe out there.
Wear
Bye bye.
sunscreen.
Bye.